So welcome everybody, and I hope you had a good night's sleep, because this is going to be exhausting. Very technical and boring. No, I don't think so. I tried to keep it simple. So just the topics I will cover, which is blood versus breath. If you measure ketones, it's a big difference. Not all doctors know the difference. Even researchers doesn't know the difference, actually. So I will tell you about the difference of the different ketones. I'll talk about units, which is also very confusing to people. What is a millimole and what is ppm, and how do you calculate from one to the other and stuff. I will talk about correlation between blood and breath ketones, or the not correlation. I will also talk about accuracy. People ask me, what is the accuracy of breath or blood? Is there a difference, or yeah? And I will also give you an example of how wrong things can go if you don't know the difference between the ketones or the measure. So I will also include a warning, which we can save for later. Yeah. So who am I? Birte told you. So I don't know. I just say I'm a software security engineer. I got diagnosed having brain tumor. That was my first grand mal, actually. And they didn't know if I had epilepsy or not. But they found a small thing in my brain, close to a center that could cause epilepsy. So for a year or two, I was having a brain tumor. That was not good, but I reevaluated life and found out what's important. So a couple of years later, I got another seizure, and I had epilepsy and got a drug, which changed my personality to a much more angry person, which is not good if you have small kids and a wife. So I still have them. So it worked out when I found a drug called keto diet. I almost call it a drug. It's addictive. So before I could switch from the drug to the keto diet, I had to prove my ability to actually be in ketosis. My doctor, he was skeptical, say you cannot live on this. So you have to prove it. So I did all this peeing on strips, blood testing, and trying to figure out my lifestyle. How can I live forever, or live until I die anyway, in this condition? And in that process, I was looking at the Ketogenesis biochemical process, and found that this acetone, why can't you just measure that, and you don't have to prick yourself, or you can actually measure a lot of times without buying a lot of strips. So I made one for myself, and it seemed to work, sort of. The correlation wasn't fantastic, but it was an indication of ketosis. So the first 2 years I was thinking that my thing, it might not be perfect, might be bad, but the more I use it and the more evidence I get, the better it is, actually. So I will tell you later about this. So, and in the process I also became a paleo nutritionist, like Birte and Tommy, the same. So now we get to the big thing, and that is all ketones are not the same. Wow. So if you measure in blood, if you measure in breath, it's not the same? No, it's not. So there are three ketones. There's acetoacetate, there is acetone, and there's beta-hydroxybutyrate. And excuse my English if I don't pronounce it right, but I'm Swedish. So, what is acetoacetate? This is the most complicated part in this talk. Acetoacetate is the primary ketone that is formed in the liver when you burn fatty free acids, and convert it to ketones. So this is the first one, the primary. This is the ketone that can be used for energy. Okay? You got that? And ketogenesis is not a binary process. It's not on or off. We always have a little bit of this, using fat as fuel a little bit, even if we are burning some sugar or alcohol or something. So when the energy need for your brain is met, it slows down a bit, and then it increases when it shows that we need more. So it's a sort of a waveform, but it follows your blood sugar quite well, actually. So when your blood sugar is low and or your glycogen stores are low, your ketosis goes up. You burn more fat. Okay? Acetone, what is this? If that is not the ketone that is created from the fatty acid, what is it? Well, it is spontaneously released from the primary ketone. So whenever fatty acid is converted into ketones, you have acetone out in your blood and coming out through your lungs. This means that the presence of acetone indicates that you are metabolizing fat as fuel. It's a real-time indicator of ketosis, ketogenesis. This might be another definition of what is commonly thought of, that beta-hydroxybutyrate, which is the last ketone, is an indicator of ketosis, but it's more a trace. So acetone is the ketone comes out of your mouth. Okay? Beta-hydroxybutyrate. Finally got it right saying it. It was hard in the beginning. That is the ketone formed from what's not used. So if you produce acetoacetate, you break down fat, and suddenly you just sit down and you do nothing. You don't need the energy. The ketogenesis slows down, but you will still produce a little bit of acetoacetate. This can be stored in blood as beta-hydroxybutyrate. And this beta-hydroxybutyrate in blood can be converted back to acetoacetate and used for energy whenever body needs more energy. So the concentration in blood is what you have not used yet. And you can use it easily if you do weightlifting or heavy exercise. So Stephen Finney, Volek, they sometimes measure that right after a high intensity workout or biking thing, they can measure nothing in blood. It's just gone because they used that energy. Okay. But they are still in ketosis. They haven't eaten anything bad or anything. They've just been using the energy. So maybe you figure out what I'm getting at. So the beta-hydroxybutyrate is how much spare energy you have. And this is the blood ketone. Okay. Any questions? No? So let's get to units of measure. I get a lot of questions about this. First of all, breath is gas. It's not liquid. And blood is liquid, it's not gas. That's main point. Gas is measured in something called ppm, which is it has no sort of unit. Well, it's a unit, but it doesn't say what. It just says it's something per million something. And this is something. The parts in parts per million in gas is volume, because it doesn't change depending on the pressure. That's still X amount of this and Y amount of the other thing. So the concentration is the same. An example, 1 ppm is 0.001 promille. It's very little, and 1% is 10,000 ppm. So you're talking about small things. Blood is a liquid, and the most common way to express concentrations is millimolar per liter in liquid. You could also express concentrations in ppm in solutions, in liquid, but then you always have to specify what ppm. Is it weight or volume? Because that's different between different kind of substances. Get that? You all look like questioning, what is it talking about? But does it make sense? Yeah? So, is it volume or is it weight? So, how do you convert this breath, ppm, to millimolar per liter? That is a very common question we get. And the answer to this is very simple. You cannot calculate millimolar per liter from ppm, because it's two different substances and it's two different medias. So just forget it. I mean, you can convert blood ketones millimolar per liter to blood ketones ppm in blood, but you can never between these two. It's just a mind error. What about correlation? If you cannot convert millimolar to ppm or vice versa, can't you do a sort of correlation? So if you measure breath and you measure blood 10,000 times a day, and you get a nice plot, and you use your magical math to calculate, to actually make a formula that millimolar is minus 0.004 times ppm in square and blah, 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 blah. If you do this, it will work right there. It's very simple. And the truth is, in some context, yes. If you don't use energy, and if you just sit down and eat a lot of nice low-carb food, maybe both will rise, both acetone and the excess acetoacetate, as you're not using it because you're just sitting down. Yes, there are studies proving that you can actually make a correlation. In real life, sometimes. If you're a programmer, you don't use your energy. You just sit down in front of your computer all day, all night, and drink a lot of bulletproof coffees. Of course, you're not using the energy, are you? So they will both rise. But always, definitely not. So if you hear somebody say the correlation is very good between blood and breath, they don't probably do much other things than just measuring all day. They're not using their energy for anything. So the correlation is good and bad. And in a clinical trials, when you just sit in your room and you eat this ketogenic food, yes, it correlates. In real life, well, I wouldn't trust it. And then you see some get correlation, some don't. And this is the explanation why. Is that clear? Yeah, you got that? So, let's talk about the methods. Measuring breath versus measuring blood. You can start with the breath. It's non-intrusive. You just blow out you empty your lungs, of course. So it doesn't hurt. It doesn't require replacement material as blood does. You have to have strips, or if you pee on strips, you need to buy new all the time. With this thing, you can actually measure as often you want. You can create actually a lifestyle by measuring, is this bacon better than the other bacon? Or should I just skip meal, or should I, what did the 2 glasses of wine I drank yesterday, how did that impose to my ketosis today? So you can measure a lot. It doesn't cost more. And it indicates the real-time creation of ketones. So if you don't get acetone, you're not metabolizing fat. It continuously leaves your lungs, so it doesn't buffer up somewhere. It just continuously. So if it doesn't come out, nothing's happening. Okay? Blood, on the other hand, it's intrusive. You stick your fingers, and if you're creating a lifestyle, you will have itchy fingers. I mean, you have they will be sort of black in the end. It hurts, and it does require replacement. You have to have a new strip, and they cost. And sometimes you fail and you get angry. I did. It indicates the level of buffered ketones, the ketone energy you haven't used, which is not real time. I mean, you can be out of ketosis and still have this, but unused buffer of energy. So, accuracy. Of what? And you're wondering, what is he thinking of now? And I'm thinking, if you talk accuracy, is that of the measure itself, or is it ketosis? If you are after measuring your ketosis, then the accuracy of measure, well, what is the most important thing? You will find out what I mean. It is breath. It depends on technique. I'm sure all of you who tested at our booth, our table down there, found out that, oops, this is how to test. You have actually to empty your last part of the lung. Because if you don't, if you just take a shallow breath, you're measuring the air. So of course, the accuracy of the technique is not the best. There's a 10% plus minus depending on your technique. But if you always do it the same way, you can actually reproduce your results very well. But it depends on you, not the sensor. The sensor is very accurate, but you are the error. So the accuracy of breath testing is not perfect. Some breath testing machines, they measure the average concentration in a small canister you blow into. Another machine is measuring the highest concentration you get out. So it depends on technique. But it has a better accuracy of indicating ketosis. Blood, it's not depending on any technique. I mean, anybody can produce a drop of blood. Maybe Hannah says it's difficult sometimes, and it could. You have to prick yourself harder. But a drop of blood is a drop of blood. It's not a big issue, and the doctors love it because they just send you to the lab. I want this, and you take a blood drop, and you get an exact measure of the concentration in that drop of blood. So the accuracy of the measure is very good in blood, but it doesn't tell you much about your current ketosis. So you see the difference. The blood has good accuracy in concentration in the drop of blood, but what does it tell you? It doesn't tell you much about ketosis. It tells you what you have stored in your blood at the moment. It's a trace of ketosis. Okay. So let's take an example. This is an example of a well-known researcher in the ketogenic diet. And he put himself, does alcohol inhibit ketosis? Do I get out of ketosis if I drink alcohol? I don't know why. I find it interesting too. And I've done this test also. So is alcohol bad for burning fat? Maybe some of you know the answer, but let's see now. First we measure before having the alcohol. Then we have some alcohol, a glass of wine or 2 or 3, I don't know. And then we measure afterwards. Let's get back. How to example is that I get back. So sorry about this. It's a new gadget. So the example here it is. So measure before and measure after. Check your machine you're measuring. Maybe it is sensitive to alcohol. Then you just measure the day after, because it's very simple. That's what I did. And if we measure blood ketones, pure alcohol contains a very little amount of carbohydrates. A lot of calories, but not much carbohydrates. So will the blood sugar and insulin rise? No, probably not. Will your body need more energy? If you drink energy, do you need to take from your spare energy? No. It's a lot of energy, so alcohol is energy, and alcohol is toxic. So what's happening in the body? The body wants to burn this off as quickly as possible. So it gets prioritized. So first it do the alcohol, then we are back to where we began. So the result is that the blood ketones, they're not needed for energy, are they? Because we just drank a lot of energy, so why should we use the energy we have in the blood? And we have to clean the body out of the alcohol first. So the blood ketones will be the same after you're having alcohol as before. So what would you think? Alcohol is good. I still burn a lot of fat when I'm drinking alcohol. Well, if you look at this blood, it says alcohol does not inhibit ketosis. So you're still in ketosis. So that is if you measure blood. If you measure breath ketones, the same applies, same rule applies. I mean, pure alcohol contains very, very little carbohydrates. Will the blood sugar or insulin rise? No. Will your body need more energy because you're measuring breath ketones? No. Doesn't. But the result is different. Ketones are not produced for energy anymore. Alcohol inhibits the ketogenesis. You're getting a lot of energy, so why take from our spare fat? It's not logical, is it? So breath ketones decrease after you're having alcohol. Are you with me? And everybody understand this? Yeah? If your brain doesn't need energy, you shut off the ketosis. So this conclusion is on the totally opposite than from the blood ketones. Alcohol does inhibit ketosis. So is there anyone who thinks that alcohol is good if you're going to lose weight? Has anybody experienced that? Has anybody experienced the other way, that if you don't drink alcohol, you lose more fat, of course. As your body cannot store alcohol, it metabolizes it right away. So the other metabolic processes are just on hold until the alcohol is gone. Then it continues again. So if you want to have a glass of wine, you can measure that in breath. You will see when you get back again to your previous level.
It's the next day that you see the ketones drop. You do that, right?
You can see it in two ways. I did an experiment like this on a flight to the US. I had a USB in front of me, and I had the Ketonix, and I had a glass of wine, and I saw it's spiking. The alcohol is, the Ketonix is sensitive to alcohol, so I could see it was spiking for 3 hours. Then I was back on the same ketosis I was in the beginning, because it's a very short time. So I can see just a little bit lower, but then it continued. So yes, so a little bit of decrease. But if I take 3 glasses of wine and I measure in the morning, nothing. 2 glasses, I can have some ketosis. 1 glass, I have better ketosis, and no alcohol, I have 3 times as much. So it does.
And the next day.
Yes. So I actually made an experiment of losing weight before I come here, and I cut out all the alcohol and dairy, and it worked. Fantastic. You can use this for many things. Yeah?
I tested last night after a few glasses of wine, and it was up at 144, and then I tested this morning and it was still 70 something, and that really surprised me, because I've been having figures around in the 40s. So is that the alcohol?
Yes. Yes. It is. You shouldn't drink and drive. And you shouldn't measure alcohol. I mean, alcohol is not part of the ketogenic lifestyle. As I said to the diet doctor, and he just looked at me and said, "What? It's not?" No, it's not. So, if you want to burn fat, to metabolize fat, skip the alcohol. That's my conclusion, and I'm sure if you ask a lot of nutritionists, they will tell you the same thing. Right, Peter? Yeah. It's not fun, but that's how it is. So, summary is that breath ketones is actually a better indicator of ketogenesis if you want to use fat as fuel and creating a lifestyle doing this, because you can test more often and it tells you the fat burning, the current fat burning all the time. Blood ketones indicates traces of ketogenesis. So of course, if you have some level of blood ketones, you have had some ketosis. But if you have 0 blood ketones, you might still be in ketosis, but you don't know, because you just used them up. So it's to me, I don't ever measure my blood anymore. I've given away my blood meters. They're quite useless, actually, in my perspective. But there is a very good use for blood ketone meters. And that is if you have type 1 diabetes or type 2 diabetes and using these new drugs, SGLT2 drugs, that gets your glucose out of in the urine. You can get into ketoacidosis. So if you have type 2 diabetes and eating this, or you're type 1, I'm sure you have a blood ketone meter to see that you're not in ketoacidosis. And you should never, ever, ever throw away these meters of blood sugar and blood ketone meters if you have diabetes. Right? Here is information about this SGLT2 co-transporter 2 inhibitor. There's been a few cases, not many, but some cases reported ketoacidosis for type 2 diabetics. So that's what I had to say. I hope you understand the difference between blood and breath measuring, that they're different ketones, that they do different things. Acetone gets out, it's a waste product. And beta-hydroxybutyrate is just a buffer of unused ketones. Thank you very much for listening.